Okay, Assalamualaikum semua. Today we continue with chapter 4, which is the inferences about a mean vector. Dalam your textbook, it is in chapter 5, page 210, but in our syllabus, it is in chapter 4, the inferences about a mean vector. Okay, actually, usually you already know about the inferences about a mean vector ni actually dalam maybe in your step method subject, but before this you deal with only univariate. Okay, so in this chapter we can see how to conduct the test of a mean when the variables involve more than one variables, which is the multivariate. Okay, so what is the inference actually? Inference is the reaching the valid conclusion concerning a population on the basis of information from a sample. Okay, so you already know what is the inference that you have learned before this. Okay, we will use sample to make the conclusion about the population. Okay, so this is the 4 topic that we will cover in this chapter, but today I will focus on 4.1 and 4.2. Okay, so we start with 4.1 subtopic, which is the plausibility of mu naught ataupun mean as a value for a normal population. Okay, in your textbook, it is on page 210. So, for this subtopic 4.1 ni, I will recall balik, I will explain a little bit about the testing of the mean value for univariate. Okay, this topic that you have learned before this in step method. Okay, so we know that we can test the value of mean using the using the t statistic and compare with the t table. Okay, before this. Okay, when we are testing something, when we are testing the parameter, which is the population, here our parameter adalah mean. Okay, we want to test whether the mu naught is a plausible value for the population mu. Okay, value mu naught is a plausible value for the population mean mu. We want to know whether the value of mu naught adalah plausible, which is logic ataupun boleh digunakan to express the value of population mean mu. Okay, so to conduct this test, we will use two-tailed test, which is the hypothesis will be mu h naught mu equal to mu naught and h1 mu naught equal to mu naught. So now we want to know whether the value of mu naught ni plausible ke tidak when we are for the population mu. Okay, so that is the hypothesis. The test statistic, okay, this test statistic that you have already familiar, which is x bar minus mu naught minus s divided dengan square root of n. X bar adalah sample mean, mu naught adalah the value that we want to test, and s adalah sample variance, and n adalah sample size. So this formula you are familiar before this. Okay, so for this test, we testing for the univariate. Okay, and then we have the hypothesis testing, we have the test statistic, and the decision rule will be reject h naught when the absolute value of T tadi, test statistic, is more than the value of T table. Okay, which is the T n minus 1 alpha over 2. So if T statistic, the absolute value of T statistic more than the value of T table, so hash not will be rejected. Bila hash not is rejected, we can say that, we can conclude that mu not tadi is when hash not is rejected, mu not is not a plausible value. When hash not is not rejected, so maksudnya hash not is acceptable, we conclude that mu not is a plausible value for the normal population mean mu. Okay, this is the concept when we are testing whether the mu not ataupun the value of mu is a plausible for the population mean. Okay, and another method to see whether hash not is rejected or not is using the confidence interval. Okay, we are using the confidence interval for mean to see whether we will reject hash not, which is the mu equal to mu not tadi, is rejected or not using the confidence interval. Okay, remember this formula of confidence interval, which is x bar plus minus t n minus 1 alpha over 2 multiply the standard deviation for x bar, which is s divided by square root of n. So how to conclude that hash not is rejected or not using the confidence interval? Remember, when 0 is included in the interval, then hash not will be accepted ataupun hash not will be not rejected. Okay, when 0 is not included in the interval, hash not will be rejected. So using the concept of that, we can conclude whether hash not will be rejected or not. So we have two methods lah, whether we want to know whether mu is plausible value for the population mean or not using the testing, hypothesis testing, and then another one we can also using the confidence interval. Okay, itu adalah konsep untuk univariate. Okay, so untuk when we are dealing with the multivariate, nak check benda yang sama, which is you want to see whether the value of mean is the plausible value for the mean of the multivariate normal population or not. We are using the Hotelling T-square dan juga likelihood ratio test. Ada dua cara, tapi gunakan konsep yang sama. Okay, in your textbook ada detail formula dan juga example dekat page 212 and also 213. Okay, so kita tengok kalau kita deal dengan multivariable. Okay, so a p by 1 vector mu naught is a plausible value for the mean of a multivariate normal population using the hypothesis testing. Okay, so mu naught vector vector mu naught, kalau kita deal dengan multivariate, kalau dia bold tu adalah vector. Okay, so hash naught will be mu equal to mu naught, okay, which is the vector mean equal to vector mu naught. Mu naught will be the value lah. H1 vector mu not equal to vector mu naught. This is also the two-tailed test. Okay, so mu dan mu naught tu adalah vector, which is the dimension will be p by 1, right? Okay, the test statistic dipanggil square of the test statistic. Okay, kita this formula, okay, kita gunakan konsep this formula untuk univariate. Kita akan gunakan konsep of univariate to create the concept of the formula of t-square dipanggil hoteling t-square when we are dealing with the multivariate. Okay, so tengok dulu yang univariate ni. Okay, this one t-square. Okay, tadi I lupa nak cerita. Kalau univariate tadi, kita gunakan T, kan? Dia punya test statistik adalah T, which is x bar minus mu naught divide dengan S over square root of N, kan? And then kita compare T statistik dengan nilai value T table. Right. Okay, so another method juga, kita boleh gunakan value of T square. Dia equivalent. T square kita compare dengan F distribution. Ingat tak apa yang you belajar sebelum ni? Okay, so T square adalah x bar minus mu square. Sebab T tadi kan, T value T kita squarekan dia. So x bar minus mu naught square divide S square over N. Sebelum ni, kalau T x bar minus mu over S divide square root of N. So T square will be x bar minus mu naught square over S square divide N. Okay, so daripada sini, okay, this part, okay, it is equivalent with this part. Betul tak? Okay, so kalau yang ni kan S square over N tadi, kalau kita darab dia akan jadi darab N over S square. Betul tak? N over S square, so N kat depan ni. Divide dengan S square, bila kita nak bawa naik atas, dia akan jadi S square power of negative 1. X bar minus mu square, so satu di sini X bar minus mu, satu di sini X bar minus mu. So this term and this term equivalent. Kita akan gunakan this term untuk create the multivariate and log this here. Tapi untuk multivariate, kita akan gunakan vector dan matrix lah, yang bold tu kan. So daripada sini, kita create this multivariate. Dipanggil hoteling t-square. You kena hafal this test statistik. N adalah sample size, X bar adalah mean vector, sample mean vector. Mu naught adalah value ni tadi, vector of mu naught. Okay, kat sini transpose. Okay, multiply S inverse, which is the variance covariance, sample variance covariance matrix inverse, X bar minus mu naught. Okay, so here will be X bar will be P by 1, mu naught will be P by 1. So transpose, so this term, dia punya dimension will be 1 by P. S inverse P by P, X bar minus mu adalah P by 1. So this term you akan dapat satu value 1 by 1 lah. Okay. Alright, so di sini pula adalah formula untuk dapatkan X bar, which is the mean vector. Okay, ada dua formula. Sama ada you gunakan this formula ataupun you guna cara biasa macam sebelum ni lah. Macam mana nak cari X bar, you just dapatkan mean untuk variable X1, dapatkan mean untuk variable X2 dan susun dalam bentuk mean vector. Ataupun boleh gunakan juga this formula. Okay. Okay, formulanya, okay, kalau yang tu, okay, kalau tengok kat sini so, X bar adalah P by 1. Macam mana kita gunakan this formula untuk dapatkan X bar? 1 over N, X transpose, X adalah, kan you susunkan N, X matrix will be P by N, right? Dia akan susun dalam bentuk kolom. So, dia akan jadi P by N, N by P. Tapi kat sini X transpose dia akan jadi P by N multiply by matrix of 1. Matrix of 1 ni adalah N by 1. N by 1. So maksudnya ianya adalah vector N by 1. Bukan P by 1 N by 1. So vector 1 ni maksudnya dia punya all the element will be 1, which is the dimension will be N by 1. Okay, bila you multiply this matrix, so you akan dapat P by 1 lah. Okay, untuk X bar. So ada dua cara lah. Sama ada gunakan cara biasa, you dapatkan mean for every variable, dan susun dalam bentuk mean vector ataupun gunakan this formula. Okey. Yang kedua adalah macam mana cara you nak dapatkan variance covariance matrix. Okay, variance covariance matrix ada dua method jugalah. Macam sebelum ni pun you boleh gunakan. Kalau macam sebelum ni kan dalam bentuk matrix tu dia punya all the diagonal will be the mean untuk mean pula apa ni, variance for every variable. Okay, so macam mana cara you nak dapatkan variance for every variable tu that you have learned before this. Cumanya dalam chapter 1 dulu Sn kan, Sn, so dia bahagi dengan n yang you kira tu, dia summation of xi minus x bar square tu divide dengan n, but now you kena bahagi dengan n minus 1. Okay, remember you kena nak cari variance matrix for sample, you kena divide dengan n minus 1. So ada dua cara, macam sebelum ni pun boleh, ataupun gunakan this method pun boleh, gunakan matrix. So kalau kat sini tengok X ni adalah matrix of X, you susunkan matrix tu kan, so dia akan jadi n by p, alright, minus dengan matrix of 1 n by 1 dan matrix ataupun mean vector transpose, so it will be 1 by p. Mean vector sebenarnya p by 1, tapi dia ada transpose kat sini, sebab tu akan jadi 1 by p. Okay, multiply dengan and then kena ada transpose kat sini, transpose. Okay, multiply dengan x, matrix x, which is n by p, dia punya dimension, minus matrix 1, multiply mean vector transpose. So you akan dapat, using this matrix, you akan dapat variance covariance untuk variance covariance matrix. You will use this untuk cari value of t square nanti. You nak replace here kan, you nak cari the inverse of the variance covariance matrix. Okay, so kalau dua variable, senanglah, you boleh gunakan boleh buat manually lah kan, nak cari variance covariance matrix macam you dah buat sebelum ni. Okay, so that is the formula to get the Hotelling t square. So also you need to know the distribution untuk t square ni. Distribution untuk t square actually adalah F distribution, which is yang kita nak compare whether kita nak reject H naught ataupun nak accept H naught. Kita akan compare dengan F distribution. So the distribution of t square will be this one. Nilai c square ni adalah distribution untuk t square. Sebab tu kita comparekan t square dengan c square. So kalau you nak tahu distribution untuk c square, you need to use this formula. N minus 1, N adalah sample size, divide dengan N minus P. P adalah how many number of variable involved, multiply by P, and then multiply dengan value from F table. Okay, statistical value from S table. F, P, N minus P, value of alpha. So if the Hotelling t square more than the value of c square, the H naught will be rejected. Bila H naught rejected, apa you nak conclude? Bila H naught is rejected, we say that the mean vector ataupun the vector of mu naught is not plausible value for the mean. Okay, kalau H naught is rejected. Okay, vector mu naught is not a plausible value for the mean of multivariate normal population. But if H naught is accepted, so we can say that the vector of mu naught ni adalah plausible value. Dia logic lah, that value is plausible for the mean of a multivariate normal population. Okay. Okay, we can see the example. Okay, actually example ni dalam your textbook, page 213, example 5.1. Okay, let's say here, the data involve of two variables. This one, variable x1 dan variable x2. Dia punya ni, ini adalah dia punya observation, kan? Alright. So first of all, evaluate the t-square for mu naught 9, mu naught transpose 9 and 5. So sekarang ni actually dia punya mu naught ni actually yang ini yang kita nak test. Kita nak test whether betul tak the mean vector 9 and 5 ni plausible, logik ke tidak untuk kita nak untuk kita nak represent the value of mean of the multivariate tadi, mean vector for the multivariate of a normal population. So sekarang untuk jawab soalan A, evaluate the t-square, so just use the formula tadi, this formula, right, this formula. So in order to find this formula, in order to use this formula, we need the value of x bar, we need the value of s, kena cari s inverse, and then barulah you apply the formula. Okay, how to get 8 here, how to get 6 here. Untuk dapatkan 8, you just dapatkan mean for the first column here. First column here, dapatkan mean, you akan dapat 8. And the mean for the second column here, you akan dapat 6, sesusun dalam bentuk vector, kan? X bar adalah mean vector. Okay, so macam mana pula nak dapatkan value variance covariance matrix? You have learned before this. 4 ni adalah variance untuk x1, 9 adalah variance untuk x2. Okay, the first column and second column. And negative 3 ni adalah variance covariance. Okay, remember to calculate this value of S ataupun variance covariance matrix, you kena bahagi dengan n-1. Okay, bila dah ada value S, you boleh cari inverse of S and then apply the formula. Last kali you akan dapat 7/9, the value of t-square. So dikata kat sini, state the soalan B, state the sampling distribution of t-square. State the sampling distribution of t-square. Kenapa kita kena tahu distribution of t-square? Because of we want to compare the t-square with its distribution. Sebab you nak tahu, kita nak reject hash note ataupun nak accept hash note tadi. Sebab tu kita kena cari distribution untuk t-square, which is the F distribution. So gunakan value of c square tadi. So n ada 3 tadi. Okay, we have 3 observation. So n is 3. Okay, p is 2. So it will be the F distribution F2, 3 minus 2 and alpha. So we can say that t square has the distribution of 4 multiply F distribution with a degree of freedom of 2 and 1. So if we want to test whether the mean value of 9 and 5 tadi ni adalah plausible or not to the mean population for the multivariate, so we can compare the value of t square here with the value of c square kat sini. So kena cari dulu nilai F21 dalam table. If t square more than this value, so we can reject hash note. If t square less than this value, we will conclude that the mean vector tadi 9 and 5 is a plausible value for the mean population of multivariate normal. Okay. Okay, another example from your textbook juga, example 5.2, page 214. Okay, this one is about the 20 healthy females. 3 component here. x1, x2 and x3 were measured and the result are shown below. Okay, dia dah bagi result here, x bar, S dan juga S inverse, sebab dia tak bagi the full data kat sini. Sebenarnya dalam your textbook ada full data dia, dekat page 215, table 5.1, sweat data. Okay, ada 20 observation. Dia ada value x1, kolom x1, ada kolom x2 and kolom x3. Nanti you boleh check the value of x bar dia betul tak. Here the value of x1 bar, x2 bar and x3 bar, and also the value of variance covariance matrix. Biasanya kalau data banyak dan juga variable more than 2, so usually the value of variance covariance matrix of variance covariance will be given. Okay, so we see here soalannya adalah test the hypothesis of mean vector is 4, 50, 10 or not. Okay, kita nak tahu whether value of mean vector 4, 50, 10 ini adalah plausible value for the mean multivariate population, normal population or not, at level significance of 0.01. Okay, so first of all kena ada dulu hypothesis testing H0 and H1. Okay, sama ada you nak buat dalam bentuk, kat sini buat mu transpose, kalau you nak buat mu saja pun boleh, tapi dalam bentuk vektor lah, dia akan jadi 3 by 1. Kat sini 1 by 3 kan, sebab dia transpose kan mu. Okay, so terus cari value of hotelling t square using the formula tadi kan, n multiply x bar minus mu naught multiply inverse of s multiply x bar minus mu naught. Okay, nanti you try check betul tak jawapannya, will be 9.74. You double check. Okay, so to see whether H0 is rejected or not, this value of 9.74 should be compared with the distribution of t square, which is c square. So cari nilai c square. 20 minus 1, 20 because of number of observation is 20. 3 here because of number of variable is 3, x1, x2, x3. So dekat sini dia punya degree of freedom for f will be 3 and 17. For the value of alpha 0.01, and you cuba check the value of f table, betul tak? It is 17.0665. Okay, so if you can see here, the value of t square 9.74 is less than the value of 17.0665. So we fail to reject H0. Bila fail reject H0, maksudnya kita accept H0. Bila kita accept H0 means that mu transpose ni adalah plausible value. 4, 50 and 10 adalah plausible value for mean population of multivariate normal. Okay, that is the way how you make the conclusion about the hypothesis testing of the mean vector. Okay. Okay, another method is likelihood ratio test. So the function of this method is equal actually with the hotelling t square test, which is we want to know whether the vector mu ataupun vector mu naught is a plausible value for the mean of the multivariate population. Okay, so we have the hypothesis H0 mean vector mu equal to mean vector mu naught against H1 mean vector mu not equal to mean vector mu naught. And then we will reject hash not if the big lambda, here is the big lambda, which is the absolute value of the big sigma hat over absolute value of big sigma hat not power of n over 2, which is we can calculate this big lambda using the matrix notation also, which is the absolute value of big lambda hat tadi. We can calculate using the matrix notation vector x minus matrix 1 multiply vector x bar transpose multiply vector x minus matrix 1 multiply main vector x bar. Okay, itu adalah how to get the big sigma hat. Okay, and then big sigma hat not will be x min vector vector x minus matrix 1 multiply min vector mu naught transpose and then multiply with x minus 1 mu naught. All of that will be in the absolute value and power of n over 2. And then if the value of big lambda here less than the value of c, then we will reject hash not. Means that bila kita reject hash not means that the mu naught, the vector of mu naught here is not a plausible value for the mean multivariate population. Okay, sama like the Hotelling T-square test. Cuma kat sini untuk likelihood ratio test, we will use the ratio of big sigma hat and big sigma hat not. But usually to test whether the value of the mu naught is a plausible value for the mean of the multivariate normal population, biasanya we will use the Hotelling T-square, but this is the concept untuk likelihood ratio test. Okay. And then what is the weak lambda? So weak lambda actually adalah big lambda power of 2 over n. So it will be the big sigma hat, absolute value of big sigma hat divide absolute value of big sigma hat not. So actually dia daripada sini lah. Okay, daripada sini big sigma equal to this. This is the formula actually. Okay, sorry. So actually sebenarnya to come out with this test statistic, it comes from the weak lambda, which is the big lambda power of 2 over n equal to this term. So kita tukar ke dalam bentuk big lambda sahaja, which is the test statistic for the likelihood ratio test. So macam mana actually dia dapat big lambda tu? So actually this one lah, daripada big lambda kan n over 2. So bila kita nak hapuskan dia kat sini, so kita kena darab dengan kat sini, hapuskan dia, so akan jadi 2 over n. So sebelah sini pun kena multiply dengan the index of 2 over n. So last kali you akan dapat this. This is the weak lambda tadi. Okay. And another theorem adalah sebenarnya from the weak lambda kita boleh tukar ke dalam bentuk t-square. So we have another formula to find the t-square using the weak lambda formula. This one. Okay, ni adalah weak lambda. Weak lambda, so actually ianya juga adalah this term. So bila kita manipulate the formula, last kali you akan dapat nilai t square this formula. The formula for t square is this one. Okay, the details of the formula will be like this. Alright, this is the formula tadi, which is the here weak lambda tadi kan, weak lambda. Okay, weak lambda equal to this term, and when we manipulate the formula, which is this part, samakan penyebut. Okay, you akan dapat this one. Alright, and then sini inverse, so kita nak hilangkan inverse tadi tu, sebelah sini akan bertukar kan, dia akan jadi tadi big sigma over big sigma naught, so here akan jadi big sigma naught over big sigma, because of here kita tukar, kat sini dah tak ada dah power of negative 1. So last kali akan dapat t square. So we use this formula of t square and then comparekan dengan value of c square, dan gunakan konsep yang sama. Bila you nak reject hash not, gunakan konsep sama dalam t square hoteling sebelum ni. Okay, alright, that's all untuk likelihood ratio test.